In this video lesson, you're going to learn about data types and operators in C#. Along the way, you're going to build this form map that you see here in front of you that works with these different data types and uses different operators based upon the data type that we are using. And then at the conclusion of the video, you should be able to complete the data types and operators video quiz. So let's go ahead and get started. Let's first look at a working demonstration of the program that we're going to build by the end of this video. The program is going to accept two numbers in these text boxes. I'm going to put a 2 right here and a 2 right here. And we're going to treat these numbers as different kinds of data based upon these buttons up here. And when I click one of these buttons, the computer is going to perform different operations on them. So it'll first treat these numbers as, like, for instance, an int, a short, a long, a decimal, double, or float. And then it's going to process this equation that we see here, like 2 plus 2, as a different operation. An operation that adds, an operation that subtracts, multiply, divide, or gets the remainder of. So let me go ahead and click int. And here the computer treated these numbers as whole numbers and performed the displayed operation here on each one. And if I were to put in a different type of number, so I'm going to put in a decimal. This is a completely different type of data according to the computer than an integer. So I'm going to go ahead and put 0.1 in here and 0.3 in here and click decimal. And here it performs the decimal operations. What this program cannot do is if I try to treat these decimal numbers as integers, that's going to produce an error. Let me show you. I'm going to go ahead and click int. Here the computer doesn't know how to work with decimals like integers. So I intentionally crashed the program to show you that it'll give me an error message that says, hey, the input string was not in the correct format. So as a programmer, we're going to have to deal with that. I'm going to go ahead and just stop the program from running and now introduce you to data types. So here I am on MSDN. MSDN is the Microsoft Developer Network, and what we're looking at is the C# API. An API stands for Application Programming Interface, and you can think of an API as a reference guide, an encyclopedia, if you will, of how to work with something. And that something that we're looking at right now is C#. So this is the reference guide for C#. And specifically, we've kind of dialed into the data types web page. So this will tell us how we can store information in our programs. And they give 3 examples in this top box. They say int a equals 1, string s holds the value of hello, and this thing called XML document, temp document equals new XML document. So what does all this mean? Well, they start off this page by saying C# is a strongly typed language. What that means is that before we can use any of these variables in this box, we always have to specify what kind of data the program should be storing, such as int, string, XML document. So that has to precede anything that we use. So anywhere in the program that we use a, s, or temp document, it has to be declared somewhere with first telling the computer what kind of data it is. So that's what that means. Okay, down below here are a list of different types of data that we can store in the program. And that little miniature program that we made and I displayed earlier worked with a couple of these. Not all of them, but a couple. We could store a byte of information. So this would be a value of 0 to 255. We could do a signed byte. So it's called an S byte. And that means that I'm going to also include negatives in this range. It's still the same number of values. For instance, this is actually 256 values because we're starting at 0. So the range would go from negative 128 to 127. That's still 256. We're just adding a sign to it. Then we could have a short, we could have an unsigned short. So here we're taking the negative away, which means we have positive numbers, still in the same amount of memory space. And then the one that I demonstrated in the program was called an int, which stores from about negative 2.1 billion to positive 2.1 billion. And just to further what I demonstrated before, I can't put a value that's not in this range inside of an int. So if I declared an int, like I did this letter A up here, down here it says that it has to be between these two numbers. So if I tried to store in a number that was, let's say, 15 billion inside of an int, it would crash the program just like it did before, because it has to be between negative 2.1 billion and positive 2.1 billion. The program that we're going to make also deals with longs and floats and doubles and decimals. But what if we wanted to put in character data? What if we wanted to actually put in words? Well, we can put a character in with the char or car, however you want to pronounce it, keyword, and it stores a Unicode character. And I'll explain what that is in just a second. And we can put those together as strings. Now, everything in the computer is actually stored as a number, but in this case, we can map to one of these Unicode character maps and represent characters and words using numbers. So how do we do that? Well, there are these character maps online. If you go to Unicode Consortium or the unicode.org website, you can click on code charts here, and you can look at different code charts from around the world. For instance, if I wanted to see our character map, the one that we use typically is called ASCII. So I'm going to click on the ASCII chart right here. And each one of these characters or punctuation or numbers maps to a particular number in this little grid. So this table up here starts with 0 up here, which represents a null character, and goes all the way down to this bottom right corner, which represents the delete character. So 7F is its maximum value, and its first value is 0, 0. These are hexadecimal numbers, and I'll go over in class how that works. But basically, it's base 16. I have from 0 to F represented here, and 0 to 7 represented in the column headings. So other character charts, you can look through here and see what they look like. For instance, I'm going to click on the Greek extended. So here is a Greek alphabet map. And you can see different numeric values for each Greek character. Okay, let me go ahead and close that. So by going through this little exercise of looking at these data types, you can really get to see that everything in a computer really does map to a number. So how are numbers represented in the computer? Well, let's take a look at a quick review of bits and bytes. We're going to go over this in class if we already have not. And the smallest amount that we can put in a computer is either a 0 or 1. So to the computer, this represents either the presence or absence of electricity. And from there, we can build up bigger numbers. So if we have a bit, 0 or 1, we can call that a Boolean. That represents a true or false, a yes or no, or an on or an off type value. But to start working with groups of bits that can represent even bigger numbers than 0 or 1, we need to group them together. So we're going to group them together as a byte. A byte will store 8 bits of information. So we're going to go in powers of 2, and as we write a number like 10110101, which is called binary, each number represents one of these columns that is a power of 2. So the far right 1 in this number right here is actually representing the digit 1. This column would be how many 2s we have, how many 4s, how many 8s, how many 16, 32, 64, and 128. So if I were to lay out the binary number in each column, the 1s indicate the values that you see above in decimal. So I have the value 128, plus I have the value 32, plus I have the value 16, plus I have the value of 4, and I have a value of 1. When I add those up, this binary number, 1011, 0101, it represents the number 181 to us. And that's how the computer is taking those little bits of information, those 1s and 0s, and turning them into something more useful, like a larger number. And then we can take these numbers and then represent characters and words, and we are constructing larger information. So knowing that, let's go ahead and start making our program and working with these different data types that we saw here on this page. To begin, I'm going to open up Visual Studio 2013. When you open it, it will look like this. To locate it on your PC in our computer lab, just click the Start button in the lower left, click All Programs, and then find the Visual Studio 2013 folder and click on the purple infinity icon for Windows Desktop. You're going to come to a screen just like this, and there are two ways to create a new project. We can click this shortcut right here. It says New Project, and it'll open up a window like this. But if the start page does not load in your window, just go to the File menu and click New Project, and it will take you to the same place. So what we're going to create today is a Visual C# app. It's going to be a Windows Form application, so click this box here. And we're going to change the name to Data Types and Operators. In our computer lab, on the PCs, you can only save inside the folder for your desktop or your My Documents folder. So by default, it's not set to that, so change the save location to either desktop or My Documents. My Documents is probably the best place to put it, and then click OK. When the application first loads, you should see a screen just like this, which is basically they've created a form app for us that's completely blank, and we get to add the content and all of the events that are going to occur with our app now. So we're in design view right now, but let me go ahead and push start. Here you can see our running application. It's a pop-up window, it says Form 1. It doesn't have anything on it, and basically all we can do is either go full screen with it, minimize it, and close it. So let's go ahead and explore our user interface here just to get accustomed to it. Okay, so let me pretend that these windows are not open. I'm going to go ahead and close them all. And the first thing that we're going to want to get to are the files in this project. To do that, I'm going to click View, Solution Explorer. And these are all the files that currently exist in our project. Another panel that I almost always have open is the Properties panel. So under View, I'm going to click Properties, which is right here. It says Properties window. It's also a shortcut of Alt-Enter. And then the other thing that we're going to need to start putting our controls on the form is called our toolbox. So I'm going to click View, and then halfway down is Toolbox. Okay, so what was that form that we had open? Well, that one is called form1.cs. So I'm going to go ahead and click on this, and we're right back to where we were. So these are going to be the most common things that we're going to have open, especially pertaining to this video. And what we're going to do is we're going to first make this form a little bigger, and we can approximate the size. We just basically want stuff to fit at this point. So with the form selected, I'm going to change the name of it. The name of the form is called its text. So over here we have in our Properties Explorer, we have a list of properties. If yours looks different from mine, you might be in Category View. All right, so this is a categorizing button right here. And if I wanted to see all of the properties alphabetically listed, I could click this button. So we want to find the one that says text. And basically what we're going to say is introduction to data types and operators, and push enter. Now you should see that change up here in our design view. So the top of the form says that. Okay, now I kind of mentioned the word controls earlier, and basically when we put stuff onto this form, they are called controls. The main category of controls that we're going to deal with here is called common controls. And common controls would be something like buttons, check boxes, labels, text boxes. So this toolbox categorizes all of the controls that you can put onto a form, and it also alphabetizes them for you. So let's go ahead and add our first control. Let's add this label right here. So a label is basically text. And here's what we're going to have it say. We don't want it to say label 1, so let's change its text property. So just like we did with the form, a label has a text property, and this is what displays. So I'm going to put data types and operators. And this is way too small for me. So what I'm going to do is I'm going to change its size. This is located in the font section. So I'm going to scroll up a little bit. And again, in this Property Explorer, you could do it alphabetically or you could categorize. So I'm going to look alphabetically for font. So I'm going to scroll down to font, and the font category has this plus and minus button that will expand and contract. We want to change size to something more of a title size font. So I want to say like maybe 24 point. All right, so I'm going to recenter this, and that looks about right. All right, the next thing that I'm going to do is I'm going to put a button right here. So let me click on button and drag one onto the form. All right, so now I have a button, I have a label, but the button says button 1. So again, I'm going to change its text property. And down here, I'm going to scroll down to text, double click on button, and type int. All lowercase, because these buttons are supposed to represent data types. And the data type that we want to use for this button is int. Now a button, by default, let me select this one, is going to be called button 1 or button 2 or button 3. Let's make this a more meaningful name for when we actually program what it's going to do. So I'm going to change this to capital I, NT, capital B, TN. So this is going to be the int button. BTN is just a short abbreviation for button. And I made up that name, it's meaningful to me, and I'm going to rename all the buttons something similar so that they kind of have that common naming going on. Okay, so let's go ahead and just copy this. I'm going to use the keyboard shortcut to do this of Control C, but you could easily just go right click and select copy. It's the same thing. And then we could also right click and paste and put another button right next to it. But again, we don't want this to be our second int button. We want this to be the short. All right, so I'm going to rename this one capital S, HORT, BTN. And then, of course, I want it to display short in all lowercase. Now I'm going to basically just repeat this process for the remaining 4 buttons. So I'm going to put one here for, that one's going to be the long, this one's going to be the decimal, this one is going to be the double, and then one more that's going to be the float. And I'm going to go back through and change these. So I'm going to, with the third one selected, third one from the left, I'm going to change its property to LONG BTN, and the L and the B are capital. Then its text property is going to be the word long, all lowercase. This one's going to be my decimal, so I'm going to change this text to say decimal in lowercase and scroll up to where it says DECIMAL-BTN. And this button is going to be my double, so double BTN, And the text property is going to say double. And then this right here will be the last one. It's going to say float in the text property. And the name of this control is going to be floatBTN, float button. Now we can push the start button up here and we can play our form. And so far we've got 6 buttons. We can click on them, but they don't do anything. So now what we got to do is we got to add in the text boxes where we can put user input. So I'm going to go ahead and click on text box in the common controls list of our toolbox, drag one over onto our form. I'm going to put it directly underneath this int. We're going to make the input larger. So just like we had this as a 24-point font, let's go ahead and do the same thing here. So in the text box properties, so up here it says text box 1, I'm going to first rename this. I want this to say operand TB1. So what this means is on the left side of an operator, we've got an operand, and we're going to call this operand number 1, basically. But TB stands for text box. So this this tells me in the code view that I'm working with a text box, and it's the first text box. So operand TB1, I have an uppercase O, an uppercase T, and I finish with the 1. If I scroll down, I want to find the font property, and I'm going to make this 24-point font. All right, so my text box just got a little bigger here. Okay, next I'm going to put a label right next to it, and I'm going to put the font size as 24, and I'm going to only put a plus symbol in the text property. And I'm going to just scroll this up until I see that little blue bar that indicates that I'm in the center. And now that I have this, basically I'm going to copy it, and that also copies the properties that I set in there. So basically the text box, if I were to drag a new one over like this, it's still in its 8.25. It preserved it when I copied it. So I'm going to go ahead and delete that one. And I want it to match what you had in the left one. However, this one, if I scroll up, instead of text box 1, I want to name this operand TB for text box 2. All right, and just like I copied the text boxes, I'm going to copy this label. So I'm going to do a click, a copy, and a paste. And I'm just going to scroll this up, and instead of a plus symbol, we're going to put an equal sign in the text field. Okay, so the next thing I'm going to do is I'm going to put the labels down here for subtraction, multiplication, division, and remainder. So I'm going to copy this one again and paste this below, put it right there, and I'm just going to paste a couple more times, and then I'm going to change the text property all at once. So here I've got 4 more. I'm going to select this first one, and in the text property, I'm going to say subtraction. And in this one, I'm going to say multiplication. And in this one, I'm going to say division. And in this one, I'm going to say remainder. Lastly, I'm going to change the name of each one of these so that we can identify them in code view pretty easily. So I'm going to select subtraction, and I'm going to go scroll up to the name property in the properties explorer over here, and I'm going to change this to subtraction, and then capital LBL for label. So that's the short version of saying label. And then I'm going to click on multiplication, and I'm going to call this my multiplication label, LBL, and click on division, do the same thing, division label, and remainder label. Okay, so now they're all correctly named. Let's see if I got this one. No, I missed this one up here earlier, so this one is going to be my addition label. All right, so this one we didn't really need to name. It was just symbolic that we are doing addition between these top two. So now let's go ahead and preview our form. I'm going to go ahead and click Start. And our form, I can type in these boxes. Everything is great, but none of these buttons do anything. So now let's go ahead and actually program the form. We can get to the code view a couple of different ways. One way is to right-click in this white space here and click View Code. There's also the shortcut of Control-Alt-0. That will also take you there. And then in our Solution Explorer, if we wanted to get to our code, we could double-click our code right here as well. So there are a couple of ways that you can get to it. So when we open it up, you're going to see what the computer has generated for you up to this point. So what you'll see here is this is the import statements for all of the classes that it takes to build a form. So Visual Studio was gracious enough to include these for us, put together that form, and all we had to do is throw on the controls. We're creating a namespace called Data Types and Operators. That's the name of our current project. And then what we're making is a class. So the class here is called Form1, and this means it inherits from a generic form class. So we'll talk more about inheritance later. Just for now, just know that the name of our class is Form1. Okay, this is called a constructor, and that is the first thing that fires when we push the start button up here. So when it makes the form, it will do everything that this thing does. So Initialize Component, what that does is that goes and finds all of our code in our designer. So if I were to open up the designer, this code was generated as we dragged and dropped these controls to the form. It's something that the computer can do for us as we're in design view, dragging a label onto the form. So here I have label 3. Over in the designer, it just added this on there. We don't have to bother ourselves with this. This is something that the computer is smart enough to do. So I'm going to go ahead and remove that and click delete. I can close the designer right now and go back to explaining the code. So basically our class is empty. So how do we program these buttons? Well, there's a really easy trick that we can do. The first thing that we can do is we can just double click one of these buttons. When we double click it, it will set up what's called a method header. So this is our int button. It added a little underscore click and named it, this is what happens when we click int button. And then inside of these parentheses, the parentheses indicate that this is going to be a method. And it's saying that I'm going to send an object with this click. And this is going to be basically the button itself. And that button has some event arguments. So these are called parameters, and we can refer to this if we need to. In this particular program, we don't need to. So we're just going to leave them there and ignore them for the time being. The next thing to identify here would be that all of these sections of code here on this page are marked off by left and right facing curly braces. So the namespace started here on line 12 and it ends on line 25. It then contains all of the stuff in between. Like our class called Form1 begins on line 14 at this left facing curly brace and ends on line 24. The constructor began on 16 and ends on 18. And our method that we're making right now begins on line 21, this left-facing curly brace, and ends on line 23. So this tells us the beginning and ending of a particular block of code. So let's go ahead and start writing on line 22, and we're going to make a variable, just like we saw in the API. So let's just take a look at that again. The API right here made an integer like this. This was an example. We have to first specify its data type, then we have to give it a name, and then give it a value, followed by a semicolon. Just to recall, an integer down here should store a value between -2 billion and +2 billion. So let's go ahead and try and store that value. So the proper procedure was to call it an int and then give it a name. Let's call it operand 1. All right, so operand 1 is going to be holding a value of whatever's in text box 1. So we called text box 1 operand text box 1. So let's go ahead and put a semicolon right there. And here you get a red squiggly line. So here I see that, hey, I want to make an int called operand 1. Why can't it take a value? Well, let's look at the error message here. It says cannot implicitly convert a text box into an int. So here what we're trying to do is the value here is called an expression. This expression is referring to a text box. And over here on the left side, we're referring to a space in memory that we've called operand 1. And operand 1 is supposed to be a number. So a number cannot be a text box. What we're actually after is what's in the text property. So I'm going to add a dot text to the end of this. I'm going to use a tab to autocomplete. Notice that the T is uppercase. And still, now it says I cannot implicitly convert string to int. What the computer is saying here is implicitly it doesn't understand how to make a string into an integer. We have to explicitly say that with code. So to do that, the API would tell us how. All right, so I want to make a integer from a string. So if I scroll down this page a little bit, it's going to talk about converting data types. Converting between data types can be done implicitly, in which the conversion is done automatically by the compiler, or explicitly using a cast, in which the programmer forces the conversion and assumes the risk of losing information. So that's what we need to do. And one way to do that would be to do this. All right, so that's a cast, that's an explicit conversion, or there is another way. Now the method shown here in the example is converting an existing number, so an int and a double are both numbers, into a different kind of number. All right, so this is a different kind of thing than turning a string into a number. So this is not going to work for us. What we need is a conversion from a string to a number, and that's done with the convert class. So I have that on a web page right here. This again is on the MSDN API for C# called How to Convert a String to a Number. And I'm going to scroll down to a chart down here under Examples. So to convert the other numbers that we're going to use from these string-based text boxes, we have to first use the convert class. And then the convert class has these methods that if we put our string inside of the parentheses, we'll convert them to a decimal, to a float, to a double, to a short, to an int. So this is the one we want right here, and this is the one that we will use in our code. So let's return back to Visual Studio, and again, if I hover over text, it gives me this little flyout, and it says string textbox.text. That means that this expression right here, this is called an expression on the right side of the equal sign, evaluates to a string. So this whole thing is representative of whatever they typed in the box. And then that string, we are trying to assign it to a container over here that's supposed to be an int. Now, if this does not match what this evaluates to as an expression, which in this case is a string does not match int, and it produces this error. That's why the squiggly red line appears. So we have to use our conversion. Now, just to emphasize why casting does not work here, when I cast using something like this, I'm going to copy this from this page over to here. We can't do this method, and it's for the reason that I stressed earlier, is that these are already numbers. So we can cast numbers to a different type of number, which is called narrowing and widening. But strings are completely different. So we can't do that kind of a conversion. We have to use the convert class. So this error still exists. So the convert class starts with an uppercase C, O-V-E-R-N-T, and then it had a method called toInt32, and that was the one that we wanted to use. In parentheses, we are going to put the string, so this is the string that we wanted to convert, and you can see the error message goes away. Now we have a second number in our form. So basically this stored this box's number. Now going back to the code, I'm going to copy that whole line and just change the 1s to 2s. So I'm going to change this to operand 2 and this to text box 2. Now we have the left text box value and the right text box value. So now let's perform an operation. I'm going to make another variable called add. All right, and this is going to hold the value of whatever operand 1 plus operand 2 evaluate to. So again, this is an expression, and this whole thing is a statement. All right, so the expression will evaluate to 2 plus 2, which is 4, and which is what we used in our example earlier in the video. And then we'll put that value in this memory address that we are nicknaming add. All right, so since it's a full statement here, this is something that the computer can execute and do. Now let's go ahead and put the result of that on the screen. To do that, we had another label right here, and that label was called addition label. And it has a text property that we're going to change from an equal sign to the number that we calculate. So I'm going to say addition label dot text equals add. And then I'm going to push tab to autocomplete, put a semicolon. And again, we have a red squiggly line indicating an error. Now, why do we have this error? Well, it can't convert the int back to a string. All right, so up above, here we had the problem of we can't make a string into an int unless we convert it. And down here, we can't do the whole thing backwards. So we can't make this, which is a string. So if I hover over this, it says string label text. That tells me its data type. Its data type is a string, so I have to put a string in it. This over here, if I hover over it, says int add. This is an integer. These two do not match. So there's an easy fix to this. I'm just right after add going to say toString with a set of parentheses. Now this number is turned into a string, and I can put that in a container that holds a string, which is addition label.text. Let's go ahead and push play and see if we get our program to work. I'm going to put 2 over here, and I'm going to put 2 over here. Now I'm going to click int, and it replaced the equal sign with a 4. So our addition worked, but the text doesn't look nice. So I want to show you something else, and it's called concatenation. All right, so on the right side of this equal sign, I'm going to put in a double quote, a space, an equal sign, another space, and another double quote. And the spaces are just to make it look nice. So I can actually take this string, this is called a literal string, and I can merge it with this string. But to do that, I have to add them together. So I'm going to put a plus sign between them. So now these two strings become one. They will evaluate to a single string and put that in the text box property here. So again, this is called concatenation, when you merge together strings. I'm going to click start, and I'm going to do that again, 2 plus 2, and I'm going to go ahead and click the int button. And now I get the nice equals 4. Let's go ahead and fill in the rest. So we've done addition. I think what I'm going to do here is I'm going to copy this line. So Control-C copies, and then I'm going to paste in one for subtraction. So I'm going to call this one subtract. I'm going to call this one, multiply. And I'm going to call this one divide. And I'm going to change the signs. This one is going to be subtraction, this one is multiplication, this one is an asterisk, which is a shift 8 on the keyboard, and division is the / right there. We also need a remainder, and that's done with a modulus. So that's the % right here. And now we can do the same thing for the others down below. For these, let's write these out. I'm going to put in subtraction. So the subtraction labels text property will take the value of, and let's write operand 1, and again, this is an integer, so I'm going to say toString. And then I'm going to append onto that by using the plus sign a subtraction symbol with some spaces around it, just for good format. Minus operand 2, and I'm going to convert that to a string. And then I'm going to add on the equal sign, and then I'm going to add on the result, which is saved in memory as the variable subtract. So subtract semicolon. All right, so now I have a complete phrase here. Oh, I forgot my addition sign right there. All right, so I just added that in, and this should be error-free. Let's go ahead and look at that. I'm going to go ahead and put in 2 and 2 and click the int button, and now we get 2 minus 2 equals 0. Perfect. All right, now we should be able to change some things. I'm going to go ahead and copy this and just change the labels. So I'm going to close this output window right here, and I'm going to change this to say multiplication LBL. This one will be division LBL, and this one will be remainder LBL. All right, so these are going to be those other labels, and we're going to change the signs. This one is going to be, that one's for multiplication, so that make that one that. Division is going to be the slash, and this one's going to be the modulus, which is the %sign. Then over here, we got to change this one to say what did we call it? Multiply. All right. This one is going to be divide, and this one right here is going to be remainder. And let's see how we did. All right, so I'm going to go ahead and push play, and I'm going to put 2 and 2, and then click int. All right, so 2 minus 2 is 0, 2 times 2 is 4, 2 divided by 2 is 1, and the remainder of 2 divided by 2 leaves no remainder, so it's 0. So those are all correct. All right, so now let's convert to other data types. This is going to be, now that we have this, we're going to do some copy and paste from there. So what I'm going to do now is I'm going to copy this code that you see right here, and we are going to do that for the short right here. So a short data type, if we double click that, we're going to just paste in the code that we made for here, and instead of converting to ints, we're going to convert to shorts. So I'm going to just change all of the ints to short. So short, and then I'm going to copy these. So now we're working with a completely different data type. All right, so this should produce a whole lot of errors. And the reason why is because we took an integer, and that's a 32-bit number, and we're trying to store it as something else. So let's go back to our API and find out what we can do about that. So we can use the int32 method to convert to a short data type. That's what we want to do. We don't want to use this one, we want to use that one. And just as a refresher of what those built-in data types are, a short is a value of negative 32,768 up to 32,767. So that's what that number is. That is its maximum value range. So we're just going to change the 32s to 16s. So this is a 16-bit number. All right, now that we have this, we also get an error right here. I can't implicitly convert an int to a short. So what can we do about that? Well, I'm going to use casting like we did, or what we saw earlier. When we scrolled down, the example said that we could do an explicit conversion using a cast. And now that they're numbers, we can do this. Okay, so let's go ahead and do that first. Let's go back to Visual Studio. And I'm going to put parentheses short. All right, so that's going to make this next to it into a short, but it sees that there's other things going on here. So what I'm going to first do is I'm going to surround this by parentheses. So this addition takes place within a 32-bit number, and then we are basically downcasting it to a short. So this is called narrowing. And there is the potential here that we are losing bits of information when we go from a 32-bit to 16-bit number. That means that we're not storing as much data. We're storing half as much. So there's the potential of losing data. But now you can see the error goes away. So we're going to do the same thing here for the rest of these. So I think to speed things along, I'm just going to copy this and change the sign. So I'm going to do that there, 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 and there. And then this was subtraction. This was multiplication. It's a asterisk. And then this is a slash, and then this is a modulus. All right, so now our short button should calculate, and shorts are basically integers, so we shouldn't notice much of a difference. We should be able to put in 2 plus 2 and click short, and it's basically the exact same thing. Let me put in a 3 here and click the int button, and you can see the int still works. But what if I put in something beyond the range of a short? Let's go back to here, and I put in that number, and I got to take out the comma. So I'm going to put in, where's it at here? Visual Studio. Here we go. All right, so 32,767. Let me take out the comma, and I'm going to click 2 plus 2, or plus 32,767. This is going to give it a number beyond the range of what it's supposed to hold. So I'm going to go ahead and click this. And you can see that it went around to the negative range. So what happened here? Let me bring this up. It went from positive 32,767 to the beginning of its range. It wrapped around its values. And that is a potential source of errors if we're trying to avoid that. But in this case, we're just going to run with it. But I just wanted to show you that. Okay, next we're going to do the same thing for a long. All right, so again, we're going to take this code up here, and I'm going to right-click and copy. I'm going to go over to the form and double-click on long. All right, then I'm going to go ahead and paste this in right there. And instead of ints, we're going to use the long data type. And I'm just going to paste this over top of anywhere I see int in this method. And now the problem is we are storing 32 bits of information, but we can store in a long up to 64. So how do I know that? Well, it's in the API. So I go over here, and where's an int? Okay, an int is in this range, but a long is much, much bigger. All right, so what is this used for? Well, I've used it to store the ticks that are in a second. So if I was working with time, I might use a long data type instead of an int. And I can get super big numbers in this range. So down here, though, this would widen to the long, and that means I go from 32 bits to 64. So if I go look on that chart again, here it is. It's a 64-bit number, so we're not losing any information. That's why we don't have to cast it. We're actually gaining extra memory slots going from an int to a long, and therefore nothing is lost. And that's called widening. All right, so over here I'm just going to change the 32s to 64s, and that would be the correct way to convert the string to a long, and then run that again. All right, so here I'm going to put in 2 plus 2, click long, and I get the correct answer. All right, now we're going to work with numbers that actually have decimals in them, and that would be these three on the right. So let me close this, go back to our form. I'm going to double click decimal, and I'm going to copy and paste in this text again. So I'm going to grab this, and I'm going to scroll down to decimal button click and paste in what we created earlier. Now let's make these all decimal. So decimal. All right, so now these are all storing decimal data types. Now a decimal can actually have space to hold an integer, but that would be wrong. So let's look at our conversion chart. To convert to a decimal, there is a method called toDecimal, and we just put the string in there. So let me go ahead and change this to say toDecimal, like this. And I'm just going to double click. So when you double click on something, it highlights all of it, and then I'm going to copy it and paste it right there. So now they're both the same. All right, so now these are all holding decimals. Let's go ahead and test our method. I'm going to put in 2.5 and 2.5 right there, click decimal, and it's doing decimal conversions and operations. Okay, now we're going to do a double data type. Actually, there's one thing I want to show you about decimal here before we move on. And that is if I actually have a number such as 2 and 2, let's put in 2.5 and 2.5, notice the error. Okay, and the reason why is because if I put a literal value of 2.5 instead of using a variable up above, I also have to include the little letter M next to these, and you'll see the error go away. And you can think of this as an M for money, because you should be using the decimal data type for any money conversions that you're making. I don't think it actually stands for that. I think it's because next up we're going to cover double, and double uses the D data type, D letter next to its numbers, and that was already taken. All right, so but it is a nice way to remember that with money, use the decimal data type. Okay, let's go ahead and change that back. So I'm going to Control Z to undo those changes. And let's go ahead and just copy this one more time, or two more times. And we're going to do that for double. And, well, I'll save the float for last. So here I'm going to put double and change all of these to match. And now we need to find the correct method to convert, because of course we can put integers where it's reserving space for decimals, but we want the decimal here. So this would round it off, and we don't want that. So let's go ahead and look at our chart, and we need a double. So we can just say toDouble. Let's put that in. So toDouble. I'm going to copy this onto our next one, push play, and if I put in 2.5 and 2.5 and click double, we get the correct math. If I was working with explicit numbers in my code, I would want to include the little letter D next to any doubles, just to tell the computer this is supposed to be a double, it's not supposed to be something else. So if I had a number like 2.5, I would put the letter D next to it. Just like above, when we had decimals, we put the letter M next to it. So this tells the computer this is a double number, and this one is already a double, but if I put 2.5M next to it, now this one is a decimal, so when I hover over it, it says decimal right there. And then when I hover over this one's a double. They need to be of the same data type, so I'd have to make this one a D. And you can see the error goes away. Okay, let me undo those changes and save it, and we got one more to do. So I'm going to double click on this float. Let's see if I still have the code pasted in there. Nope, I don't. So I have to copy this basically. I'm going to copy that, paste that in, and change all these to floats. So I'm going to take this and make all the data types the same. Okay, so now we have to change from a double to what? Well, it's not going to be obvious, so we're going to go from, we want to make it a float, so we have to use this method, to single. All right, so the reason why is because a double takes 64 bits of information, and a single will take 32. So we're going to use this method. Let's go ahead and do that. So over here, I'm going to change where it says double to single with a capital S. Copy it, paste it right over top of that, and now we're good. We should have all floats. Let's go ahead and push play, and I'm going to put in, let's do something different, 3.14 and 3.14, and then click float. All right, and here you get those numbers. So they are represented differently in the computer, so each one of these is slightly different. And again, you can't mix and match. For instance, I have a floating point number in here. If I click int, I should crash the program. Let's do it. So I'm going to click this, and I get break. It says you can't do that, so I'm going to go ahead and stop it. We'll rerun it. And conversely, however, if I widen a number like 5, let me put 5 in both boxes, 5 will actually go into decimal, and it will go into double, and it will go into float. But I can't do the other way around. I can't do like 3.14 for pi. I'll put it in again here, and then I can't downcast it into an int. So that's a problem. So this is the program. We finally got it working. It's complete. So now you will go to Schoology and turn it in. So to do that, what you're going to need to do is locate your Solution Explorer window right here. If that were closed, let me pretend it's closed, and I'm going to click on the View menu. You can get it back by clicking right here. All right, I'm going to shrink my window down a little bit here so you can see everything. And the next thing I want you to do is just right-click on Solution and click Open Folder in File Explorer. So that's going to show you exactly where you saved your stuff. And you're going to highlight all your files, just like that. Then you're going to right-click, and then you're going to say Send to Compressed Zipped Folder. And I'd like you to put your last name on your folder for me. All right, so put last name only. And then you're going to open up Schoology. So let me open up Schoology, find where it says Data Types and Operators Program. You're going to open that up, and then click the Submit button. The Submit button has a File button. It's not labeled, but when you hover over it, it will have a flyout that says File, and then upload that file in Schoology there. When you're all done with uploading your program, then you want to move on and complete the Data Types and Operators video quiz. So that's going to review all the things that we just went over in this video.